And we're live.
Looks that way, doesn't it? Yeah,
real? Is this happening?
it's happening. Hey, I'm gonna
Okay.
switch our sides because I feel like I'm looking away from you.
Exactly. Like, you're okay. Now you're here. Okay,
Yeah,
so
yeah, yeah.
we're talking about thing. So if this is real, so welcome 2025 for Rad's live stream, right?
Yeah, welcome everybody.
Yeah. So yeah, welcome everybody. I'm definitely excited to be here today. That this is a program that we used to. I mean, I'm going to use the term we, but I'm very new at Redis. So more my friend here, a guy that used to do this a lot in the past, but we are going to resume the live stream programs and then try to get to know you a little better. So I think first thing first, I would like to see how is Redis doing. So put in the chat how you're going in this Friday and tell us where you are connecting from. So it's
Well,
always
and,
good to know.
and while everyone's doing that, we should probably introduce ourselves.
That is true, right? That is true. I mean, I feel that guy. You don't need introduction. You are basically the alias of Redis. So, but anyway, I think you can start, and I can go in second.
Yeah, so my name is Santa Claus, and every year I deliver presents quickly and efficiently and rapidly using Redis to all the good boys and girls across the world.
And he's here right now with us. It's real.
Now, I'm a developer advocate at Redis. I've been here for a few years, and I do a lot of community work. I go out a lot of events and speak. I create sample code. We did a fair bit of live streaming at one point, and then we're bringing it back, which I'm very excited for. And so, yeah, I'm Guy, and I'm a developer advocate at Redis. Ask me your questions. I'm not afraid.
Yep. It's part of the job description, right? Hey, Ricardo here. Also a developer advocate at Redis, and I'm super excited to be here. This is actually my 5th month with the company, so some of you might know me from my past with working with AWS and Confluent with Kafka. But now my bread and butter is all about Redis, and I gotta tell you, I fell in love the first time I used it. So I'm happy to be here. And also, just like Guy, I'm not afraid to answer questions, even though sometimes I might answer them incorrectly. And if I do so, please correct me. I think that's totally fine. So yeah, Guy, let's talk about what is the latest on Redis these days. Maybe something that you have been playing with recently, some geek thing that you have been building.
Yeah, so I've been, of course, everyone's doing all the hot AI stuff right now. It's all the rage, and so I've been playing a lot with image embeddings and using Redis as a vector database for that. I tend to be a JavaScript first kind of person, so JavaScript's my go-to language.
Mm-hmm.
It's not to say that I'm a JavaScript developer. I'm just a developer. I've done lots of things over the years, but JavaScript tends to be my go-to. It's good and accessible for a lot of developers. And so I've been using Hugging Face to create embeddings of images and text and those sorts of things, and then loading them into Redis and various permutations of that. So putting together a couple of workshops along those lines. I've been doing some conference talks where you upload all your meme twins into, you upload a bunch of memes, embeddings of memes and the memes themselves into Redis, and then you take a picture of yourself and it tells you which meme character you are. And so that's been the thing that I've been speaking about most lately.
Nice.
I come up for meme character is if the background is dark, then it tends to put me as the world's most interesting man, which is very flattering. Of course,
the one with the beer.
Yeah. I don't always drink Dos Equis, but when I do, right, other beers are available.
Right.
Do not take this as an endorsement of Dos Equis, although I do enjoy it. The other thing that I come up in is the dad, Paul, from American Choppers. The meme where they throw the chairs.
Right.
so that's what I've been working on lately. I've got a couple other projects in the works that hopefully folks will be seeing here soon. I don't want to spill the beans on those a little too soon. So
that's nice.
What have you been working on, Ricardo? Oh, hang on. Before we do that, I see a comment in chat here.
There's a comment here.
Yeah. So I got an email from DA, message from, oops, we both clicked it, didn't we?
Yeah. we just did a race condition here live.
Yeah. No, after you. No, after you. Yeah.
This is deadlock.
Yeah. So Diego says, can you create an MMO RPG using Redis? And I think Diego may have watched me stream in the past because for a while there, I was working on what I called Redis Mud, which was a text-based MMORPG. MUDs were what you had before MMORPGs, and I would live code that on this channel. So I hope that's you're a longtime viewer, Diego.
Maybe he's remembering from previous live stream. This is good. This is good.
Yeah. That was a lot of fun to do. But no reason you can. And actually, I think it would be a good candidate for your database for an MMORPG simply because of the speed. I mean, there's a lot of gaming use cases around Redis.
I would say so. Yeah. And speaking of which, I think that's kind of a very circumstantial, because one of the things that I was working on, not recently, but like a couple months ago, is kind of in a game also using Redis. I wouldn't say it's a kind of a multiplayer RPG game, but it's something that you can definitely play with a bunch of people online. I'm going to put here in the chat the link of the game, and
let's get fancy, and if we can create a QR code for it. Yeah,
let's do it. I'm going to share here with you, and then let's do the QR code for this. So while Guy is creating the QR code, let me explain what this is. So everybody probably remembers the game Hangman from 5th grade, and we were playing during recess time, and then I kind of created one of those with Redis, but primarily kind of to study Redis myself. And I was kind of trying to kind of put into some usage some of the probabilistic data structures from Redis, top K in particular. And then I kind of create this game. It's very easy to install, like clone the REPL. Actually, let me share my screen so I can tell a little bit of it. Share a screen. And then it's going to be
it's infinity. What do we do?
Horrible. What would you do? We are an infinite loop here. So this is basically kind of the look and feel of the game, right? When you install and then you work in a browser. So there's almost like 500 different words that you can try to guess online. And then this is all backed by Redis. So you can play locally. You can install via Docker Compose up, right? And then you're good to go. Or if you want to be fancy and then play with your games, you can deploy this using your AWS account. And then you can basically use the Terraform code. Everything is going to be done for you automatically. And then the same game is going to be available for you. And I think it showcases very well like the need for Redis to speed, right? And like I said, if you want to try yourself like with one of the probabilistic data structures, that's a good way to go as well. All right, let me stop sharing. And then Diego, tell us where you were connecting from today. What part of the world you were texting, right? It's kind of weird.
Where are you typing at us from?
Yeah, where are you typing at? Yeah.
And I think there's probably about a 20-25 second latency. So when we ask the question, we have to then scroll and drag things out. So
right, there's a little bit of buffer. Where are you coming from, Guy? Where are you texting?
Me?
Yeah.
I wasn't sure if there was a capital G or a lowercase g on that. So. I'm in Columbus, Ohio.
Okay.
You can't be much more in Ohio than Columbus. It's pretty much dab smack in the middle.
Right.
So yeah, everyone's got to be from somewhere, and that's where I'm from.
Okay. Yeah.
What about you, Ricardo? Where are you coming from?
I'm in Raleigh, North Carolina. So it's that's where I call home.
The weather's better there.
Yeah. I mean, not today. Today is kind of sunny, but it's too chilly. So it's okay. So for folks that are joining us today, probably you have read that the topic today is going to be like recommendation systems with vector databases. And this is true, right? We're not talking here about random things and just to change the subject. But we wanted to take this time to kind of get in touch a little bit more with everybody, and then kind of let everybody know that, number one, this is actually going to be like a ongoing thing from now on. So the live streams are going to gradually be more frequent throughout the year, and we're going to be covering different topics, somehow Redis related, but who knows? Sometimes we might be talking about geek stuff or technologies that are not necessarily all about Redis, right? And the topics that we love the most is what can you build with Redis? I think that's the most interesting ones. And if any of you that are watching us right now have any ideas about, like for example, our friend Diego, like can you maybe create an MMORPG, right, using Redis? That can be a topic from the future. So who knows? And also, an important update. We are also with the live stream program try to do something that's kind of probably is going to help a lot of people, which is answering questions that were sent to us, and we can answer them live. Like you name it. Like maybe you have a question that has been like stalling for a very long time on Stack Overflow, and you want us to kind of discuss here with everybody. We can do this, or we have a Discord server, right, Guy?
We do have a Discord server. Why, yes, Ricardo, we do have a Discord server.
We do this, right? Right. Remember, we have something like this. And then I think this is where these days most of the people from the Redis community are posting their questions. So for those that, yes, please, yeah. So for those of you that never joined this community, please do so. Join Discord. This is where all the Redis geeks hang out, and then you can also use their channel for posting your questions. And we're going to bring them here and collaboratively with you answer them, or try to answer them, right? So our friend Alex is joined from Seattle, right? So cool. Diego is talking to us from Chile. It's very nice as well. Hi, Alex. Hi, Diego. Diego's saying, I'm very interested in vector index implementation in Redis. So me too.
I'm interested in Rust, honestly. I keep trying to get into it, but I really need a solid project to sink my teeth into for it to internalize.
Right.
I figure out borrowing, and then I don't look at Rust for 3 months, and then I forget it, and I have to learn it again.
Who does this? Who does this, right? All right. Actually, that's a very good segue for us to introduce our guest today, because he is actually going to show us a little bit of how vector indexing implementation works at Redis. And yeah, let's pull up our friend Justin to the show. So
okay, let's bring Justin in here. Hello, Justin. How you doing today?
I'm good. How are you, Guy?
Doing all right. Getting good grades. Future so bright, but I don't have any sunglasses. So
I'm being a good boy. I'm behaving.
Have you been being a boy? Are you going to get presents from Santa this year?
I hope so. Yeah.
Right. Justin, so nice to see you here, man. And so I'm going to let Justin introduce himself in a bit, but for all of you know, we're all part of the same team at Redis. We're part of the team called Developer Experience, right? Although Guy and I, we are part of the developer relations team, and Justin has the nicest fancy job ever. He spent his whole day working with AI and vector database. How cool is that? Justin, how do you feel doing this work?
I love it, honestly. I think it's a great time.
Yeah. I bet. I think that's a good segue for you to introduce yourself and tell us what you do. I'm gonna definitely ask you later about when I grow up, what can I do to become Justin one day? So be prepared to answer that question. But yeah, please tell us a little bit about you.
Sure, I'll take it away. Thanks, Ricardo. Yeah, my name is Justin, and I'm an applied AI engineer at Redis. And so I get to build a whole bunch of different things, from demos to code snippets to maintaining some of our libraries that people use with Redis. And it's all about AI use cases, from large language models and retrieval augmented generation, or RAG systems, to agent support. But one of my personal favorite topics, and something we'll talk about more today, is recommendation engines with vector databases. Nice.
That's so cool. That's so cool. This is the area of expertise that you have, like previous experience before joining Redis, if I understood correctly, right?
Right.
So specifically, like recommendation systems, not only vector database. I think for your career, I think working with vector databases is the foundation of what you are actually trying to accomplish, right? I would say it's or am I incorrect? Like this is actually the meat of what you are trying to accomplish.
I would say it is if we're using the food analogy, I would call it the dessert of what I'm trying to accomplish, because
dessert. Look at that.
Because it's way tastier, and it's the part that you end on. As in, I've tried other systems and they weren't as good, and then I found vector databases and I realized this is what I've wanted the whole time.
Nice. Nice to put it.
I've eaten all my veggies. Now I can just eat chocolate cake with Redis for the rest of my life.
Here you go, everybody. Chocolate cakes with Redis. So that's probably going to be our next swag at conferences. So Nice. Good to know. Good to know. Yeah. So, just I have a question for you. I'm gonna let you lead on in your presentation and demo, but I have a question for you about uh, for those of us that don't know what recommendation systems are. Can you tell us like a little bit of what this is? I know you're gonna show it, but I mean, for those that are connected with the like, why should we worry about recommendation systems in 2025?
I would say it's because everyone uses them all the time, and you definitely encountered it. Everyone in the audience has used, either a movie streaming service or they have a Spotify account. Or if you go onto YouTube, your homepage has, a subset of videos that you can watch. And these are all recommendation engines. Like a dating app is a recommendation engine because they filter down, hundreds or thousands of candidates and they show you like the top 5, top 10.
Right.
And you don't want just random things appearing in your YouTube feed or your Facebook feed. You want things that are relevant to you. And so a lot of machine learning in industry is a recommendation engine, which is kind of strange because as someone that was, both academically and kind of self-trained, most of what you come across in the textbooks and the online courses are not recommendation engines. They're other versions of machine learning, which are also powerful, but for whatever reason, recommendations just get skipped over in a lot of the educational resources. But they're probably the bigger chunk in terms of actual, industry use cases.
That's so interesting. And now that you mentioned the examples like YouTube and Netflix, I always wonder about how much effort there is behind scenes to make them be as accurate as possible. Because my feeling is that as a user, as I kind of consume the content that has been, like you would use the word pushed, right?
Yeah.
The content that is pushed to me, as I keep watching them, I think there has to be like a continuous reformulation of the recommendations, right? So it's not something that is static, right?
Yeah.
So I always wonder if oh man, this should be like very complicated to do behind the scenes. We're all glad to you here today because we're going to show this how this works. So Justin, take away, my friend. Show us how the magic is done.
Showtime.
Showtime.
Let's bring your screen up here. You ready for your screen to be shared?
I'm ready. Yes.
You sure?
I closed all the
going once, going two.
There we go.
Okay, let's put you on top there. I should not be in the pole position. There you go.
Oh, beautiful. All right. Yeah. So like you said, recommendation engines or systems can be very complicated, but they actually start out fairly simply. And so what I'd love to kind of walk through today is, starting from square zero, there's a zero because we're computer scientists. Can we walk through and kind of build one and see what it looks like and see what the ideas behind these are? And then we can add complexity and, more advanced features as we go.
Right.
So the example I have here is, like we talked about earlier, it's going to be a movie recommendation engine system. And for that, the first thing you need is a whole bunch of movies. So really all I pulled up here is, don't see my notebook, let's just execute some imports. There's a common data set that a lot of people use for systems like this called the 25,000 IMDb movie data set. It's a CSV available online. We host it as well for people that want to go through it and kind of play around with some of these notebooks. Mm-hmm. Literally all it is just a CSV file of data scraped from IMDb. And so if you see what this looks like, I've just loaded it into a pandas data frame.
Oh, nice.
And this just, each individual row. So you have the title of the movie, the runtime, the rating on a scale of 0 to 10. You get the genres. So it's a list of action, adventure, biography, crime, drama, horror, et cetera, et cetera. Then you have a description or an overview. You have some keywords, director, cast, writer, year, and then the path. So what IMDb URL it's linked to.
Right.
Standard stuff. But again, for the sake of this example, instead of using the full 25,000, we'll skim it down to 5,000.
That's fine. That's fine.
So ultimately, let's go back to, what is the goal of a recommendation engine? So you log into your movie streaming platform and you want to watch something, but maybe you don't know what. You need something recommended to you. There has to be more than just a blank page. They show you this. So what did you get shown? And that's kind of a hard question because, again, there's 5,000 films in this very small toy example. There's way more in reality. Which ones do you pick? And there's different ways to do this, different approaches. A starting point for a brand new user could be just, sort by the ratings, show them, the hottest new blockbuster films, or show them the newest stuff. That works for the first day. But then after, you watch those top 10 movies, then what? You want something new, you want something different, you want some other recommendations.
Right.
So then how do you kind of personalize it? Because once again, your tastes in movies and mine might be different. And you'll probably notice if you ever go to someone else's house and see their Netflix streaming account, they get different recommendations. So why is that? How do you get these systems that will continuously recommend things that are relevant to you based on some feedback they're getting, and also personalized to you and not just to everyone else?
And just a note for that, for those of you that are parents like Guy and me, who has children, recommendation systems are very useful for you to know what your kids are doing these days, because every time I look into my kid's Netflix account, I can kind of have an idea about his interest, and the interests from this year are way different from the last year. So I can tell you that. So that's one good use case for recommendation systems.
Yeah, I know I get all kinds of recommendations for anime stuff because my 21-year-old son's downstairs watching anime all day.
Yeah,
exactly.
And so maybe this will help you understand kind of why that is. And if you want to, quote unquote, hack the system so you get more relevant recommendations for what you want to see.
Yep.
You can know how to, I won't say hack, but like, interact with the system so it behaves the way you want.
Right.
So this is a machine learning problem. So like all good machine learning problems, I'm going to spend, in reality, a huge amount of time cleaning the data. For the sake of this demo, it's already been cleaned.
Right.
But because we're in Pandas data frame, we're just going to drop a couple columns that we don't care about, like the runtime or the writer, the year was published in. We're going to drop anything where the overview is empty. So if you don't have a text description of the film, we're just not going to consider that for this application.
Right.
And turn some of those lists that were actually stored as strings inside the CSV back into lists. So the genres, the keywords, the list of casts, they're just back into lists. So now they're in the data frame. We can pull out individual items. And once again, because we're going to use Redis, just make sure. See, now we have nice clean data. Let's go ahead and create a Redis client. I just have a Redis instance running locally in a Docker image. You can connect to whatever database you want. And that's fairly straightforward.
Nice.
Cool. So now we have a Redis client. Now let's talk about what we're ultimately going to do with Redis, which is search over and try and filter down some of these films relevant to the user. There's different approaches to different machine learning architectures when we talk about recommendation systems. The one I want to talk about today, I'd say, is probably the most intuitive, and it's called a content filtering approach. The idea is you want to filter down this huge amount of content based on similar content. In order to do that, we need to define, what are the characteristics or features of these films. In Redis, we're just going to create a search index here, and we're just going to specify a couple things for housekeeping. So what is the index name, movie recommendations, how do you want to store it? All these movies are going to be stored inside JSON documents inside of Redis. And then we can just define the fields. So we care about the title, we care about the rating, we care about the genre, the overview, keywords, the cast, and the writer. Really, we're just specifying, when we're doing a search, what are the things we're going to search over, and what is the data going to look like? And that's just here. So once again, you can just pass it a list of dictionaries, and it takes it.
Can I make a quick question, Justin? Actually, two of them, if you allow me. Like the first one, like for those of us, including myself in this, because when I started working with Redis, like it was a long time ago, right? Which is a shame for me because I work at Redis, right? But I'm not familiar with the term of an index in Redis. Like, I think this is something new, or maybe something that is not very common. Developers are not very familiar. Can you give like a TLDR of what an index is in Redis?
The way I think about it, and this might not be technically accurate, but it works in my brain, is it's kind of like the table of contents of what you can search over.
Okay.
So the individual documents, you can store them without an index. You can just add stuff to Redis and pull it down by an individual key. The same way you could,
Nice.
Open up a book and turn to a page, and the page is there. The table of contents kind of tells you where to find things quickly.
Mm-hmm.
You kind of go through that and say, oh, I care about the title. Show me all the things where this title is at. So just a way to organize and help you search over. So if you want to pull over, show me all the films with a rating greater than 7 out of 10 stars. This index helps you do that search, so you can pull out just those films.
So it works like a metadata on top of data structure, if you will.
Yeah.
And when you create it, all the fields become searchable in a way, right?
Right.
Like with a rough analogy, when you create a table in a relational database, and then you can start querying for individual fields. That's interesting.
Yeah.
So That was the first question. The second one is you mentioned something that is I always kind of a wonder myself, and let us know in the chat, everybody, what if you ever wondered this as well. You mentioned that you can also store like the content that's going to be searched added at Redis, which is I presume is going to be all the movies and the recommendations, but also the metadata front end, right? Is this kind of a typical practice, like in the same database you put your, let's call it, transactional data along with your search data all together? Is there are any benefits or trade-offs by doing this?
There can be benefits in terms of just conciseness if everything is within Redis.
Mm-hmm.
The downside, and so again, going back to the movie example, you probably don't want to store your entire 3 gigabyte film within Redis.
Right.
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 And so the larger things, like let's say you have an image thumbnail, if it's small, you can probably put that in Redis. If you have a giant poster that's going to fill everything up, maybe not. If you're doing something like book recommendations, maybe you store, the summary, the title, the author, things like that. But the entire full content of 800 pages of text, you could store that somewhere else and just search over the things you care about, and maybe not do a full text search over the entire novel.
Right. Right. Nice. Thank you. Please carry on.
Sure. So yeah, so using Redis VL, which is our vector library built on top of Redis Pi, and this is all Python, of course, we're just going to define the search index and then formally create it by passing it the Redis client. And then to actually load our pandas data frame into it, basically 2 lines. You turn the data frame into a set of dictionaries, and then you just do index.load data. So now, once you actually execute these 2 cells, we'll create the index, and it takes about half a second to load all these 5,000 movies into Redis. So if we're curious, and actually hopefully I have this up right now, we're going to switch over to another tool quickly. So this tool is just called Redis Insight. It's a pretty good GUI that I really like using that just shows you, what is inside your Redis instance.
Could you make that a little bit bigger there, Justin? I think it might be hard for everyone to see.
Yeah, let's expand that out.
Yeah, and give it a good Command plus as well, because it's tiny, fuzzy little font.
Yeah.
Can I Command plus? Oh, I can't Command plus on this one. My apologies. Okay. Maybe I'll just talk through and hopefully people can figure out what this is about. So this is just a list of every single movie in an individual JSON document. So if I select one on the right over here, it's literally just the JSON structure of what is the title, what is the rating, what is the rating count. Exactly what we expect. It's a JSON object within Redis, and you can just manually inspect it here if you want. And so this just shows that, this is what the data actually looks like in Redis. There's nothing magical going on. It's really kind of what you intuitively expect. It's also a good way to know to make sure your data actually loaded and there's no errors. So looks like I did everything right, which is nice.
Right.
Right.
Another more like a curiosity question that I have is for you is that in your domain area, which is kind of an AI and AI research, I think these days you got to be pretty well rendered with data engineering, right? Because what you're doing, like cleansing data and then like executing and check it to see everybody is the role of the data engineer. I think both roles, data science and data engineer, is kind of mingling these days. Am I correct in this?
You are. I kind of find it very interesting and also rewarding and challenging the same way that the field of data science, machine learning, AI, it's very nebulous in terms of where the boundaries are between data engineering, software engineering, applied AI versus practical AI versus research scientist versus ML operations, which is like how you deploy a model to production.
Right.
The lines are very blurry between all these different roles, and so it makes sense that even if you're not an expert in all these things, you have to be able to be, conversant in all these tools.
Nice.
Yeah.
And we have a question here from Kijano Flores. I'm gonna bring this up, and the question is: does Redis VL integrate with PyIceberg? And you care to comment about this?
I can comment by saying I have no idea what PyIceberg is. So
I know what Apache Iceberg is. So basically, it is kind of this meta format that many data lakes are using these days to exchange data in a, let's call, neutral form, right? So you can replicate data from one data lake to another and not necessarily depend of the specific format that some vendors have. So it's a very popular platform these days. But most likely, I don't think we have currently integrations for this with RedisVL. But with that said, that is exactly one of the objectives that we want with these live streams, to understand your use cases. And our friend Kijano, if this is important to you, we can definitely bring to the people inside Redis to make this happen, which is exactly the team from Justin. So you're talking to the right people here.
I will definitely take this back to the rest of our team and see what we can do about this.
Nice. Thanks, Kijano. And yeah, go ahead, Justin.
Cool. All right, so now that we have all our films within Redis, now we want to go to the actual recommendation part of saying, how do we find something that is useful and relevant to someone? So let's say we have this imaginary user, John, and he's been using the platform for a bit. Maybe at first he was shown the top 10 movies, the most high rated movies. And he's watched at least one of them, and he's given it the thumbs up saying, hey, I like this film. The idea behind content recommendation is we say, okay, we're going to use that as a signal to say, find similar stuff to this film. So for this example, let's say John's favorite film is 20,000 Leagues Under the Sea. Classic Jules Verne novel, turned into a pretty good movie. I recommend it if you haven't seen it. I enjoy it. And so you can see kind of what this is like. So once again, we have the title, the rating, the genres, the overview, the keywords, et cetera, et cetera.
Right.
What a lot of people will do, and this is a totally valid thing to do for a recommendation engine, is if you want to find something similar to this movie, look at the genre. Maybe this person likes action, adventure, science fiction movies. So let's go ahead and find more action, adventure movies for John. RedisVL makes that pretty easy. Once again, because we have the genres indexed in our search index, we can just grab similar genres. So if we import first, let's grab the genres list from the favorite film. In this case, it is action, adventure, sci-fi. Let's go ahead and create a tag filter. And so this tag filter will just say, when I conduct a search over Redis, limit all my results to make sure they match at least one of these genres. So now we're going to go ahead and run a filter query based on this tag. And I want to say, Redis, give me back the title, the genres, and the overview, and just give me the top 10 results based on these matching criteria. And we'll just print them out and see what they look like. So 10 other movies with the same genres are The Lost World, Lost Continents, Unknown World, Planet Outlaws, etc., etc.
Nice.
Fantastic Voyage, several different ones. And you can see that the genres are adventure, fantasy, sci-fi, or adventure, sci-fi, action, family, sci-fi. There's some similarity there, which is good. If we look at the overviews, maybe some of these are pretty similar. So if we look at the first one, what's the very first film they resulted in? The Lost World.
Uh-huh.
So the description is the first film adaptation of Sir Arthur Conan Doyle's classic novel about a land where prehistoric creatures still roam. Maybe that's similar.
Yeah.
Not a bad guess. It's not horrible. It's not like a really, weird silent film from the 1920s compared to 20,000 Leagues Under the Sea.
Right.
But probably not perfect. There's probably something better we can do.
Yeah. So is this the part where you can kind of optimize your recommendation? Is there like a mechanism or an implementation pattern that people should follow?
There are several things you can do. And again, this is kind of like, step 0 of building a recommendation engine.
Okay.
We filtered down our content from 5,000 films to maybe, 1,000 that are within these categories. But we can probably do better. We're still only getting top 10 results. There's way more than 10 action adventure films in our data set. We just happen to, limit this down to 10. There's several things left on the table. Probably some things that are on that list are even more relevant. So the question is, can we further refine our results, further narrow down our search pattern to do something even better?
Right.
The answer is yes. And so let's go ahead and take a look at what that looks like. So we filtered by genre. We can keep doing that, but maybe we can do something a bit better. So what if we look at certain keywords in the description? So I've go ahead and hard coded a couple of things here in terms of keyword filters we can add to search over the overview. So again, if you like 20,000 Leagues Under the Sea, maybe you're really into submarines and seas and captains. Let's go ahead and add these as keyword filters. Add this to our filter expression. So now we're going to filter both by genre and try and match on at least one of these words somewhere in the film's description. And hopefully that'll give us, a narrower but more specific and more relevant list compared to the movie you saw earlier.
Right.
So once again, if we go ahead and just run this, you can see the results. And now the most recommended title is Submarine X1. Okay, still an action movie, still matches there.
Right.
What's the description? During World War II, the British Royal Navy used experimental midget submarines to raid German warships in Norway. Maybe. Could be relevant. What about some of the other ones? Captain Sinbad. Action adventure. Okay, that's a good start. To marry Princess Jana, Captain Sinbad must battle deadly obstacles and fight El Karim, the evil ruler who also wants to marry the princess. Could be a good film.
Right.
Maybe it's related. Has a sea nautical theme. There's some similarity there. But what about this film, Yellow Submarine? It's an animation adventure.
Is that the song for the Beatles, or?
It is. The Beatles agree to accompany Captain Fred in his yellow submarine and go to Pepperland to free it from the music-hating blue meanies.
Oh, look at that.
So you can probably see why this came up. It has the word submarine in it. It has the word captain in it.
Right.
Probably not what we're looking for. And so now we get down to the real meat of the question of recommendation systems. You can try and build more tools, more filters, more manual adjustment to say, oh, match on this word, but not match on that word. Include action adventure, but limit family because you care about these things. You can do a lot with that. And for people that have tried to do that, you probably realize it'll get hairy very quickly. And you really don't want to go in there manually picking keywords, manually trying to define what should or shouldn't match. You're going to get some spaghetti code if else statements very quickly. So the question kind of becomes, well, we still have our basic idea of we want to find similar content. So now, how do we define similar? So far, we've been defining it as having the same features, like the same genre, the same keywords, maybe the same cast or crew or director, if that's what you want to define as similar. But again, that's kind of clunky and very specific and, painful to manually tweak and tune. There's way too many knobs you can twist by yourself that you really don't want. So rather than go down that road, which could take way too long, we can take a step back and say, okay, let's redefine what it means for things to be similar. And this is where we get into the world of vector databases. And this is where we actually get into the world of using someone else's deep-powered machine learning models. And we kind of have to switch over and now talk about vector embeddings. So we're going to pause for a second and, take recommendation systems out of our mind and just talk about, vector embedding models. The idea behind these things is they are a form of large language model, not quite the same as ChatGPT, but kind of a precursor to it, where what they will do is you can give it a block of text. It can be one word, it could be a paragraph, it could be even larger. And it goes through a machine learning model, and it'll put out a fixed size array of floating point numbers.
Right.
And those numbers represent the kind of the semantic meaning of that text. And so it's a deterministic thing. So you pass it in the same sentence, you'll get the same vector out every single time. But what's really powerful about these models is if you pass in similar statements, they'll give similar vectors. So if I say, who is the Queen of England? And I say, what is the name of the Queen of England? They're very similar. And so you'll get very similar texts, arrays out of that.
Oh, so that's what you meant with the term semantic meaning. That's the semantic part. Semantics. Okay, got it.
But importantly, it's not just keyword matching. So if you look at, who is the Queen of England and what is the name of the Queen of England, if you do keyword matching, Queen, England, that's the same. But importantly, these vector models will actually capture the meaning of the sentence. So if I say, who is the King of England and who is the monarch of Britain, words are completely different. But semantically, those sentences mean the same thing. And those vector embeddings that will come out from the model from both these sentences will be very, very similar. And the reason why that's useful is now you can do a vector similarity search to find similar things.
Let me ask you this, Justin. Can you combine, I understand what you're describing right now, which is a better way to do the search based on the semantic meaning, but can you combine with the approach that you explained before, the filtering with the vector search?
You can. So you can put those things together. And let's see kind of what that looks like.
Oh, nice.
So step one, let's go ahead and create these embeddings. Once again, using Redis VL, we're going to do two things. One, we're going to just take the overview, the title of the film, and all the keywords, and concatenate them together into one big block of text.
Mm-hmm.
Then from Redis VL, we're going to use kind of one of our integration packages and pull out one of these embedding models, which is stored on Hugging Face. So the HF is for the Hugging Face text vectorizer. And we're just going to specify which model we want. So in this case, we're going to use the sentence transformers, all mini LLM L6-V2 model. We support pretty much anything from Hugging Face. We have integrations with OpenAI, Gemini, Vertex AI to use other embedding models as well. For the sake of this example, we'll use this one.
Right.
So this will take a minute because now we're going to generate 5,000 vector embeddings from all these films. This might seem like a long time, especially if you want real-time recommendations. The important thing is you only need to do this exactly once. So once you have a vector embedding for a film or a book or a song or anything, you never need to regenerate it. This is a one-time thing. You load into your database, and then they're good to go for the lifetime of that system.
But question about that. Curiosity question for me. But what if the source data that gave birth to those embeddings, those array of floats, they change in the backend database? Like for some reason, someone updated them. So is this a common practice to kind of regenerate the embeddings and then restore them on the vector database? Or what do you recommend for situations like this to keep them fresh?
Sure. I mean, it depends on, now it's very use case specific. If the data is actually changing, then you can regenerate the embeddings. But you don't need to do it for the full system, just for the data that changes.
Okay.
Yeah. So again, if you have 5,000 objects and one of them changes, you only need to update that one.
Okay.
It's useful to try and pick features that don't change very often.
Right.
Also things like this. Again, going back to maybe like movie examples, the description of a film isn't going to change. The authors or the writers, the directors, they're going to be basically constant.
Yeah, true. Yeah.
But maybe you have something going back to the idea of like a dating app. Maybe someone updates their photos or changes their bio description.
Right.
Those things can change every now and then, but still, it's not like on a per second. It's every couple of days or maybe a couple of weeks.
Right.
So what if I noticed the model name there has a V2 on it? What if I want to use V3 or V4 or use a different model that has better characteristics for my problem? Will I have to revectorize everything?
You will, because all these models are kind of internal to themselves. So you want to make sure that you're never comparing across different models for two reasons. One, models can give different size outputs. So version 2 might give a certain size vector embedding, 500 floats, maybe 1,024. Version 3 might give 300. Or 286 or some other number. So the math won't work out if you compare different size arrays, but also even if they are the same size array, the math will technically work, but you'll probably just get gibberish numbers because each kind of vector dimension might be capturing a different meaning.
So now that explains why I was trying myself like the things in the past, and then I kind of did the preliminary embedding model using OpenAI, and then I stored on Redis, and then I kind of tried to reuse your example with the Hugging Face, and then for some reason they didn't match. Now I understand why.
Yeah, so that'll be why. Yeah, so that's it. So now we have the vector embeddings. They're all generated. And once again, they're just arrays of floating point numbers, one per film. We want to store these in Redis, but to do that, we first have to update our index. So previously in our example, we didn't have vectors defined as a searchable field within our index. Luckily, we don't have to recreate the entire index. We can just add this to the existing thing. So we're going to add a new field. It's going to be of type vector. I just give it the name embedding. This could be called movie embedding, something else. The name is arbitrary.
Right.
We give it the type. You have to give it the attributes. So you have to tell it what size it is, and all these models will have a known size. You tell it what search algorithm it wants to use. Flat just means we're going to search over every single vector in an exhaustive fashion. For 5,000, that's very doable. For 500,000, you'd probably want some approximation algorithms, which we support as well. But I think we can get away with flat for here.
Got it.
And then for the distance metric, we want to define what does it mean for two vectors to be similar. We're going to use the cosine similarity metric here, which basically means if you're taking two vectors in some space, what is the angle between them? If the angle is very small, it means the vectors are very similar. If the angle is very large, it means they're pointing in opposite directions. There's different methods. You can use like Euclidean distance. So if you look at like, the point between my fingers, what is the shortest line distance between those 2 points? That can be a metric as well. Cosine is kind of what a lot of these models are based upon because it's always bounded between range of values, usually either -1 and 1 or 0 and 1. So we'll stick with that.
Right. So before you move forward, Justin, just a quick comment. Actually, I'm going to comment about a comment that our friend Diego did. That he actually asked a question: is memorization a common pattern in vector-based recommendation? So I would assume, based on the one you have shown so far, that the combination of this kind of filtering part versus the factory part is what the memorization common pattern is he's talking about here, or something different?
I'm not sure. I mean, when I think of memorization, I think of, storing a computed value and using it later on and not recomputing it if you don't need to.
Right.
So in that sense, yes. Like again, like normally when people think about, machine learning systems, they think the machine learning algorithm has to run once per time. In this case, because we're using vector databases, we don't. The embedding model, which is probably the slowest part of this whole system, that gets run once per film, and then we're good as long as we want to go. The actual computation now for each recommendation, every time you want to refresh and get a new set, actually just ends up being a database lookup. So it's incredibly fast. It doesn't actually hit the machine learning model at all, because now the recommendation part is only ever doing vector similarity search, which is just multiplying arrays of floating point numbers, which computers are pretty darn fast at.
Yeah. Nice. Thank you.
So if we update our index and go ahead and kind of reload our embeddings into it, once again, that takes less than 2 seconds to add another 5,000 vectors into Redis and update the schema. Now we can do vector similarity search all throughout our database.
Nice.
So going back into saying, okay, well, now I want to do similar films. Once again, I want to figure out, can I get some movies that are similar to 20,000 Leagues Under the Sea? And now, instead of just doing a genre filter, I'm going to do a vector similarity search. Say, now similarity is defined as, do they have similar descriptions? Do they have similar overviews? So I'm going to grab the movie vector from 20,000 Leagues Under the Sea that was generated from its description. And now I'm going to do a vector query with Redis VL and say, give me the top 10 results that are most similar to these things. And once again, for the return fields, I'm going to say, just give me the title, the genres, and the overview.
Got it. When you say top 10, is that parameter number of results over there? Okay, got it.
So this will return the number of results. You can make it more. So if you want to get the top 20 or the top 5,000, it'll sort them in most similar order.
Right.
So they'll always be ordered as well, not just similar. And here are the results. Now, unsurprisingly, the top result with a distance of 2.3 times 10 to the -7, so basically 0 with a bit of rounding error, is 20,000 Leagues Under the Sea. Naturally, you probably drop this one because you've already shown it to them, but the math is working.
Right.
The second most similar one is called Captain Nemo and the Underwater City. Probably a good sign that, this is the sequel that's being recommended.
Right.
Or what about Around the World and Under the Sea, or The City Beneath the Sea, or The Deep? This seems more relevant. And importantly, we're not just doing keyword searching on the title. So it's not like I searched for the word City Beneath the Sea. Nowhere in this vector search did that come up. Or even something like this movie called The Deep. Again, keyword matching probably wouldn't find this. It's an action film. Okay, what's the overview? Based on actual events, a fisherman tries to survive in the freezing ocean after his boat capsizes off the south coast of Iceland. So description-wise, that seems somewhat similar to what we're looking for with 20,000 Leagues Under the Sea. Again, is it a perfect recommendation? Maybe not, but you can see why this would seem similar based on that description.
And in most cases, I think it's not perfect at all, right? Because when you were presenting that part, I was trying to kind of visualize how the UI of this on Netflix would look like. And what you just show is the equivalent of when you have a movie open on Netflix, and then there's that option. You also would like to watch.
Yeah.
So you started with your inline, the movie vector equals Jones Fave embedding values, the first position of the array. That's the movie that is open on Netflix right now, whatever it is. and then you're trying to find the equivalents semantically ones to the one that is open, right? So that's how it works in the real life. So it doesn't have to be perfect. I mean, I know for sure that sometimes Netflix recommends something that's okay. That's a far reach, but yeah.
But this is where you can see where it's coming from. I mean, a lot of these components are, I'd say,
Right.
more similar than our previous attempts.
Exactly.
And once again, to your question earlier, can you combine vector similarity search with other filters? So now we're just doing vector similarity search. But once again, I don't say give me only action or give me only film or only adventure movies. They happen to be that, coincidentally, because unsurprisingly, the descriptions are similar.
Right.
But once again, I could say, give me only science fiction movies or give me only movies made before 1940 if we have the year as an index field. So you can combine vector similarity search and those filters on top of it.
Interesting. Nice. Yeah, that's quite powerful. And you can kind of mix and match the approaches, right? It doesn't have to be one or the other. You can.
Yeah.
Your use case is going to drive the right approach, probably.
Yeah. And so this is where personalization comes into, because again, this is now one set of recommendations. Out of these top 10 films, maybe you'll watch a second one. That can then be the new key to your second round of recommendations. You can paint it from there. And now you can continuously get, every time you watch a film, you get a new batch of recommendations of something that's similar to it. Because you can kind of walk your way through this vector space, always finding similar films to what you've seen last time.
Right. Interesting. Nice. We actually have a very interesting question here from Justin Cechmanek.
Hi, Justin. How you doing?
Hello.
Justin used to be on the DevRel team, so.
I know him from the videos on YouTube. He's quite good. So So his question is, this is really cool. I can't stand Ben Stiller, so I'm with you, Justin. I don't like him either. Is there any way I can ensure I get recommendations without this horrible acting in a movie, yet still use vector similarity? I think that goes back to what you said before, Justin, about you can create like maybe an exclusion clause, like do this, all this, but accept this, something like this, or is there any other approach that we could use?
So this is where I'd say, if you really don't like, oh, by the way, welcome, fellow Justin. Always good to know there are more of us out there.
Yep.
Yeah. So similar to how we had, keyword matching before to say you must include submarine or must have an exact genre match. You can do the opposite, say must not have so-and-so as an actor.
Okay.
And so that would actually look very similar. Let's see if I can live code this. This is going to be a risky move. I'll try it.
It will be the equivalent like a where clause in SQL, and then you kind of accept this, right? Something like this.
So no Ben Stiller would look something like this. And if I don't get it right.
No Ben Stiller variable.
So it would appear on the field actor. You want to create a tag filter. And you want to say not equal to Ben Stiller.
Interesting.
And you just add in the filter expression equals no Ben Stiller.
So just for
apologies to any fans of Ben Stiller out there, by the way.
Yeah, like, I was thinking about this. Like I said out loud that I don't like Ben Stiller, but this is not very empathetic of me. So for those of you that like, we respect you, okay?
Justin's entitled to his opinion, but
Right.
You can also do, just for Justin, only Ben Stiller.
Right. That's fair. I think that's fair.
Yeah. And now, once again, it would match only on films that have him as an actor.
Well, dodge, duck, dip, dive, and dodge, right?
Yeah. Nice.
Yeah. I was talking about, I was out with a friend last night. We were talking about the movie Heavyweights. If anyone remembers that classic.
No.
It's a movie about kids going to fat camp, and Ben Stiller is like the over obsessed. It's actually almost the same character as like from Dodgeball, where he's like super fitness obsessed and trying to get everyone into crazy shape.
Right.
So I feel like it's the same character, but he just grew up and went from hosting a summer camp to try and get everyone super fit into like owning a gym, trying to get everyone super fit. Yeah. So if you like Dodgeball, I recommend Heavyweights.
Dodgeball. Okay. I love Dodgeball. Dodgeball, old school. I think those are my favorite old movies for comedy, at least. Nice.
Yeah.
So Justin has a follow-on question.
Oh, does the filter run before or after the vector similarity search? That is a great question, and I don't know the answer to that. That is a lower level Redis question, but the results would be the same. So now you're just talking about, which is more efficient. I'm sure our very capable engineers that actually build raw Redis that work in C, which is a language I don't work well in, have picked the most efficient way.
Do you want an idea, Justin? Justin Cechmanek, no, Justin Castillo. If you go to Redis Inside right now, there is the debugging option you can enable on. So by the time you execute the command, you're going to see the order in which they are actually executing. That's a hack. I don't know if this is going to work, but we can try. If you go to the bottom of Redis Insights,
was it the profiler?
I think it's a profile. Yeah.
Cool.
Yeah.
So now if we actually run this cell, let's see if I did the syntax correctly.
Right.
Oh, this might be case sensitive. I'm going to take out this filter expression. Oh, actually.
Tags aren't case sensitive.
Oh, they're not? Okay.
No.
Well, it turns out Ben Stiller is not listed as an actor in any of these films.
So it works.
There we go. Perfect.
Actually, Justin Castilla, not Cechmanek. I am reasonably sure that it's a filtered search as opposed to a hybrid search. So filtered searches filter the values out and then apply the vector similarity, as opposed to a hybrid search, which is combining those scores together. I know that's the thing that's being worked on.
Right.
For the sake of running this, let's switch to a filter that we know works.
Right.
So now if we run this, so once again, we get some results, and let's see what happens in the profiler. Now, apologies for people that can't read this. I'm not sure how to make the text larger.
Yes, if you press Command plus, you can increase the font size.
That may not do that inside of an Electron app, which is what a Redis Insight is.
Yeah, it doesn't work here, unfortunately.
Oh, really? Okay.
Yeah. So all this gibberish that you're seeing is the hex code of the vector. So don't worry about that. But it does give you kind of like the raw Redis FT search command that this filter becomes.
Okay.
Yeah. So if you're ever curious what's actually happening, on the Redis command line, it's this FT search over the movie's recommendation index with the genres filter tag, does a k-nearest neighbor search with the embedding vector, and returns, again, the overview, vector distance, and it sorts by vector distance. So you get the closest ones.
Got it.
Okay.
Yeah. I think for us to be able to figure that out, we have to go one level below of the profile, which is kind of the execution model on the Redis part. But we can actually double check this and with the engineering team. But yeah, it's good stuff, man. I like it, Justin.
Yeah. And so that kind of concludes my demo of content filtering.
Right on time. Right on time. We are.
Yeah.
It couldn't be more perfect because it's at least on East Coast side is 4 p.m. here, so we are right on time. Does anybody else has any more questions? A quick comment here from Kijano Flores. I can see this working really well for excluding an SFW type of content.
Yeah. So I'm almost certain that, if you were to build out, you can have hard limits to say if anything is tagged as adult or inappropriate or, 18A, 14A, you can say don't show these things to kids' accounts or to anyone not interested.
Right. Nice. Thank you, Kijano. And yeah, let's wrap up here. And well, first of all, Justin, you're amazing. Thank you very much for spending this time with us on a Friday. Like, who does this, right? Who does invite a guy like you on a Friday to talk about vector systems unless you're passionate about the topic? So, right. So really thankful for your time here today. And also thank everybody that was present today. You made our day today. So keep coming back. As I mentioned in the beginning, we are kind of going to resume this program of live streams. I think that's the best way, besides going to the conferences and meetups ourselves and be in person with you. But I think that's another way for do this in a more scalable way, right? So we are going to keep bringing different topics, Like I mentioned before, it doesn't have to be all about Redis. We're going to talk about what is going on the implementation and the developer ecosystem out there. So we're going to also bring these topics is important for us as well. And yeah, if you have any questions, please reach out on Discord server that Guy shared in the beginning. Also, Stack Overflow question, just tag us there, and then we're going to be able to see it. And yeah, this is it. Guy, one set of last words.
Well, where can people learn more?
Yeah,
I'm just reading chat. Justin says that it was a great presentation. So Justin,
nice.
Justin likes you. Justin.
Thank you, Justin.
Justin likes Justin. Okay, Justin. Remember Airplane, the first movie, Airplane?
Roger.
Yeah, Roger.
You know, there's probably a joke buried in here of can I get a vector, Victor?
That could be a great demo.
I just got an idea for a talk.
Nice.
But yeah, so where can people learn more? Do we have a repo for your code that everyone can look at? And what resources do we have?
Let me grab the link very quickly and I'll share this. So this demo and several other ones, all about recommendation systems and other things you can do with the Redis Vector library, are available in our GitHub repo called Redis AI Resources.
Okay.
So we have several different notebooks all around different types of recommendation systems, content filtering, and other ones we haven't talked about, including collaborative filtering and two-tower filtering models as well. And a host of other machine learning and AI applications all around, vector search, RAG applications, agentic RAG, et cetera, et cetera, et cetera. So there's a lot of good content there for people that are interested in learning more.
Yeah, I was about to say that whenever you have a chance, also take a look on the other projects that we have on this Redis developer organization on GitHub. There's a lot of cool projects in there.
Absolutely. So, yeah, everybody scan that QR code. That's got the URL. It's also down here in chat. So if you don't trust the QR code, you can just take a picture of that URL, and I'm gonna paste that over on LinkedIn as well, because when the host posts it doesn't go to LinkedIn. So
right
there we go. Yeah, that was really good.
Yeah, I think that's our cue to say goodbye, and wish everybody a great weekend, and take care. Keep being awesome, and come back to the next one.
Yeah, absolutely. It's 4:04 right now, and we're ending the stream because we don't know where we're at, but we'll be here in the near future.
All right.
That was really lame, but thank you anyhow.
All right. Take care, everybody.
Bye.